Hello everyone. I hope you all are keeping good health. Today we will start with a new topic, adjacent angles. Now what do you mean by adjacent angle? Here there are two angles, angle 1 and angle 2. Let's trace these angles with different colors. Angle 1 with red, angle 2 with green. Here we can see that both angles are having a common vertex. Here A is a common vertex. Next, there is a common arm with both the color. And the non-common arms are on the either side of the common arm. Means they have no common interior points. Then the two angles are considered as adjacent angles. So, to come in a conclusion that the angles are adjacent, they should have a common vertex, a common arm, and the non-common arms should be on the either side of the common arm. Moving to next topic, linear angle. Again, here there are two angles, angle 1 and angle 2. Again, I am tracing both the angle with different color. Yes, what we can see here is, again they have a common vertex. There is a common arm with both the color, and the non-common arms are opposite rays. That is, they are forming a straight line. They don't have any common interior points, and as the non-common arms are opposite rays or are forming a straight line, we can finally say that the angles in a linear pair are supplementary. Everything is same as we have in the adjacent angle. The only condition differ is of supplementary. In linear angles, the sum of both the angles is equals to 180 degree. Or we can say that the angles in a linear pair are supplementary, as the non-common arms are forming a straight line. Next is vertically opposite angle. Now let's consider that there is a line L. Next, there is a line M. Yes, they are crossing each other, or we can say they are intersecting each other at a particular point. Name it as O. So, how many angles are there now? 1, 2, 3, 4. When two lines intersect, the vertically opposite angles are equal. Here, 1 and 3 is a first set of vertically opposite angle, and the second set is angle 2 and angle 4. Moving to the second part of the exercise 5.1, which is based on these three concepts. Question number 9. Is angle 1 adjacent to angle 2? A diagram is given to you. Now, this figure you have to check whether angle 1 is adjacent to angle 2. What I will do is, I will trace both the angle with different color. Here I am tracing angle 1 first and then angle 2. Yes, here you can see O is a common vertex. Then OC is a common arm. Next, OA and OE are the non-common arms on the either side of common arm. As all the three properties are satisfied here, so we can say yes, angle 1 is adjacent to angle 2. Next, again here you have to check the adjacent. Angles are AOC and AOE. Again, first we will trace angle AOC. It means first you will color A to O, then O to C. Next, A to O, then O to E. Yes, again start with the properties. Yes, the first is common vertex. Yes, it has a common vertex. Then both the angle common arm. Yes, OA is the common arm as it has both the color. Now the non-common arm are OC and OE, but they are on the same side of the common arm. So yes, we can say here that angle AOC is not adjacent to angle AOE as the non-common arms are on the same side of the common arm. Next, do angle COE and angle EOD form a linear pair? Linear pair means non-common arm should make a straight line, or the angles in the linear pair are supplementary. Yes, first we will trace angle COE. Next, angle EOD. Again, starting with the point number 1, common vertex. Yes, there is a common vertex. So, common arm. Yes, OE is the common arm. Both the color are there. Now the non-common arm should be the opposite rays or should form a straight line. Yes, here you can see OC and OD is forming a straight line and they are the opposite rays. So yes, both the angles are forming a linear pair. Next, you have to check whether the angles given to you are supplementary or not. Indirectly, we are supposed to check whether the angles are linear pair or not. Again, tracing BOD. Next, tracing DOA. Again, common vertex, yes, it's O. Common arm, yes, it's OD. Non-common arm, are the opposite rays or are they forming a straight line? Yes, they are opposite rays, they are forming a straight line. So we can say yes, they are supplementary. Next, we are supposed to check whether angle 1 and angle 4 are vertically opposite angle or not. Now to check out the vertical opposite property, there should be two lines which are intersecting each other at a particular point. So first you will trace the two lines which are forming X or which are intersecting at a particular point. Yes, here AB and CD are the two lines which are intersecting each other at O. Now checking 1 and angle 4. Yes. Angle 1 and angle 4 are vertically opposite angle. They are opposite to each other vertically. So we can say yes. Now we are supposed to find what is the vertically opposite angle of angle 5. So again, first you will trace the two lines which are intersecting each other. Now you have to find vertically opposite angle of 5. Now in the diagram you can see angle 2 and angle 3 both are the vertically opposite side. So we will write it as angle 2 plus angle 3. Moving to question number 10. Which pair of angles are vertically opposite angles? The first part is you have to find out all the pairs of angles which are vertically opposite to each other. Again, first trace the two lines which are intersecting each other. First set here you can see it's 4 and 1 or 1 and 4. We can change the order. And the second one is angle 5. On the other side there are two angles. You will write with a plus sign. So angle 5 is vertically opposite to angle 2 plus angle 3. Moving to second part of question number 10. Which pair of angles are linear pair? Linear pair means a set of angles which are forming a straight line or which are supplementary to each other. Here we will trace one line at a time. First, I am tracing this slanted line. Now, there are two angles on top and there are three angles below the line. We will consider right now only the two angles which are forming the linear pair. So here, angle 4 and angle 5 is the first pair which is forming a linear pair. Moving to the second line, trace the second line now. Again, above the line there are two angles, below the line there are three angles. We will use two angles and they are angle 5 and angle 1. So the two pair of angles which are forming linear pairs are angle 4 and angle 5, angle 5 and angle 1. Moving to question number 11. In the following figure, is angle 1 adjacent to angle 2? Give reason. The diagram of figure is given to you. Here first, as we are supposed to find whether the angles given to you are adjacent or not, we will trace both the angle with different color. First I will trace angle 1. Then I will trace both the arms of angle 2. Now one by one we will check the properties. Yes, there is a common arm as this particular arm has both the color. Yes, the non-common arms are on the either side of the common arm. But what about the common vertex? As you can see, here the vertex are not same. They both are starting from different vertex. So they are not adjacent. We can write angle 1 and angle 2 are not adjacent angles because their vertex is not common. Yes, as we can see, the vertex is not common, so we can say that angle 1 and angle 2 are not adjacent angles. Moving to question number 12. There are two sums. In both the sums, you are supposed to find the values of angles x, y and z. To find out the values of x, y and z, we will use the properties we have used so far. Now in this figure it's very clear the first property that will be used is vertically opposite angle, as there are two lines which are crossing each other. Yes, by using vertically opposite angle property, the very first set is solved. Yes, x is equals to 55 degree. The value of x is known to you now. Moving to next set, it's y is equals to z. Again, it's a vertically opposite angle, but both the value is not known to you. Now, after vertically opposite angle, we will use a linear pair property. So I'm using this particular line, the shaded line. Now it's on you which particular set of angle we want to use. Here, I am using this particular line and I am using the set 55 degree and y. As they are forming a linear pair, so the sum will be equals to 180 degree. Shifting 55 degree to the right hand side, you will get the value of y. Shifting means positive will become negative now. Solve the right hand side. Value is 125 degree. Now as the value of y is 125 degree, from equation 2 we can say z is also 125 degree. So yes, now the values of x, y and z is solved. Second part. Now in this figure again you are supposed to find the value of x, y and z. First you will trace the two lines which are intersecting each other. Now use the vertical opposite angle property. First set is 40 degree and z. So z is equals to 40 degree by vertical opposite angle. Now in the next set you can see there is y and on the other side it's x plus 25 degree. So these are second pair of vertical opposite angle. They both are equal. Next, we will use linear pair property now. Now I am tracing this line. Now here either you will use the three angles that are above the line or we will use the two angles that are below the line. So I am using only the two angles here, y and z. They are forming linear pairs, so the sum is equals to 180 degree. Now z value is known to us. From 1 we can put z as 40. Now shifting 40 to the right hand side, you will get y as 180 degree minus 40 degree. Why minus? Because on the left hand side before shifting it was positive. So after shifting it will become negative. Solving the right hand side, the value of y is 140 degree. Now y is clear to us. What we will do is we will use this y to get the value of x from equation 2. Just putting the value of y on the left hand side. Now shifting 25 degree. You will get x as 140 degree minus 25 degree. Solving the two, you will get value of x as 115 degree. Moving to question number 14. Now again in the adjoining figure, name the following pairs of angle. The first is obtuse vertically opposite angles. Vertically means first shade the two lines which are crossing each other. Here you can see angle AOB and angle DOC are acute angle. They are less than 90 degree. So the angles left are AOD and BOC. So the sets are angle AOD and angle BOC are obtuse vertically opposite angles. Next, adjacent complementary angles. It means the two sets of angle which are adjacent to each other will make 90 degree. Here you can see this is a straight line and OE is forming a 90 degree on it. Now on the left hand side there are two angles which are combining to get this 90 degree. So the angles are BOA and AOE. Equal supplementary angle, yes, means 180 degree. But the two angles which we are using to form this should be equal. So here using this ray OE, you can see angle BOE is equal to angle AOD. So the answer is angle BOE and angle EOD. That's all for today. I hope all the part is very clear to each one of you. Thank you everyone. God bless you all.